Hey, what's up guys? Welcome back to another tutorial on the BLE board. This time I'm actually going to walk you through a mini project that I was working on that's part of a much larger project, but this little step here was so cool that I thought I'd make a quick video on this. So basically what we have here is an Arduino clone over here, and this is what I call the cheater board, and there's more information in the description below. But it's an ATmega 328P-PU breakout, and it's communicating to the BLE board via a software serial interface. So just TX, RX, ground, and power going over to the BLE board. And from the Arduino clone, we're doing serial.prints of data to the BLE board. That data is caught and then automatically sent up to the smartphone wirelessly via BLE. And we're receiving that data and printing it out in a serial monitor or serial console type interface. So this is kind of cool. It's like a wireless serial monitor window. And you can see here that we're receiving data once a second, and it's just a simple counter value that we're incrementing and then sending it over. So it's just a test program here. But we can also send data from the smartphone down to the BLE board, and then that is communicated down to the Arduino board through that software serial interface. And what I have it doing now is just simply echoing it back. So when I send data from the smartphone to the BLE board, I should get it right back. So what we can do here is type in ping. And as soon as I send ping, we will see it pop up there immediately since it is echoed back. So there's a lot of useful functionality here that we can go through, but it's a very simple project, and this can be expanded on obviously into much greater projects, and that's kind of what I'm planning here. So now that we can send real data to and from the smartphone, we can have buttons and sliders and all kinds of stuff and control anything we want now to an Arduino. So that's kind of the cool thing too. So now the BLE board is set up just as a radio interface. So the Arduino can run all of our heavy duty, heavy lifting code for our project, where the BLE board just handles the wireless piece. So anyway, a lot of cool stuff here, but let's first jump into the connections. So on the BLE board, we have two pins that are labeled TX and RX. So TX over here, RX over here, and if you jump over to the wiki, you'll see in the pinout here, we have the two green pins, and these are for our serial UART, and you see RX and TX. So I have TX connected from the BLE board to the RX pin down on the Arduino. So let me pull open that Arduino code, and you can kind of see here what I'm doing. So we have a software serial setup going on here. So TX pin's on 3, so that goes over to the RX pin on the BLE board, and then we set that software serial interface up, and then kind of go through this very simple code. We set it up, we're running it at 115/200, and then in the loop there, we're simply just going through checking to see if any data has come down, and if the data is available, we read it out and immediately just print it out. And I've got a little delay in there to make sure that we catch all of the characters in that while loop. Now, if there's no data available, we'll just do a BLE.print line of the counter value that we're just continuously incrementing once a second. So that's all the code. And I'm not going to dive into this line by line, but very simple, and I'll make this available in the description as well. So now let's jump into the Atmosphere IDE, and we'll actually create the BLE code to run all of this. Okay, so we've got the Atmosphere IDE opened up here with the project you just saw working there, and I will make this available for download, so you can simply go over to File, Import, and bring in that .atmo file. Just make sure that it's ATMO, not .txt, so make sure that file extension is correct for you to import that file. And then you can kind of play around in here and explore all these elements and connections further, and make modifications or do whatever you want to do. So let's jump right into this. But first, actually, let's take a look at the project settings. So in here we have the UART driver parameters, and the important one to point out is the baud rate. So I have it set for 115/200 right now, but that might be a little too fast for the software serial interface. It's working right now, so I'm going to leave it alone, but if you need to slow that down to 9600, you could do that pretty easily right there. Okay, and then of course in the code view here we can see in the setup that we do have the default initialization here, which includes the UART init. Okay, and so there's a couple different ways we could really do this, and this is just one way, and it may not be the most efficient way, and it's not perfectly proved out. It might not be completely bug free, but it works right now. So the way it works now is I'm actually pulling the UART. And you can see here we have a task, and I drag everything you see here is just dragged over from the toolbox. So I dragged the task over, and it's pulling the UART every 200 milliseconds. So it runs 200 milliseconds after boot up, and then runs every 200 milliseconds, and then pulls the UART. So you can see here we're executing that UART read function, and again that's just dragged right over from the toolbox. You can see UART read, and then if you kind of follow this, you can just see we're doing a UART read right on over, and it passes the return value. I'm having some issues with my mouse. There we go. The value returned is what triggers the connector. We grab the value, and then we append the value to this label here. So you can see we have the serial window there, and it just builds on it. So that's what gives you that sort of cool flowing serial monitor window kind of effect. We could easily set that to set value, and oops, not that, right here. Set value instead of append value, which would just set it to whatever the value was. So it would clear the whole thing out and just set it. And I'm not going to really get into every nitty-gritty detail of this. Maybe certain functions we'll jump into, but you can see alongside this here, this flow is also a parallel path, and this code here actually handles the it actually keeps track of the line count as as the data is being displayed in this label, and as soon as it hits 9 lines, it'll actually clear the window, and then whatever that 9th line was, it will set it. So that's what this does right here. So you can see we have a function here that's just keeping track of the lines. So you can see if we ever have real good data there, increment the line. If it's ever greater than 8, set the line count back to 1. And the reason it's doing that is because the line is actually not going to be at 0, because whatever that 9th data was will actually be at line 0. Okay, and then return line 9. And then you can see over here in this expression, we check to see if the count was ever at 9. And if it was, then we have that expression is true. Connector here, expression true. And then we execute this function here, and I'm just going to jump into that real quick. And you can see it returns message, okay? And the message is whatever that data was, whatever that 9th data was. And I know I'm kind of going fast here, but I'll circle back here in a second. And then that message here is actually now a set value. So instead of appending, it's setting it, which is basically clearing the whole label out and setting it back to what the data was at 9. So anyway, that's kind of how that whole thing works. And there's a couple things in between here that I do want to talk about. So like you saw that was message. So if we jump into code view of the UART read here, I changed a couple things. And if you looked at the default, actually I should do that real quick. So if you looked at the default code of a UART read block, you can see right here that it sets it up for you, and it gives you, the local variables here. But I needed access to these variables globally, so I actually pulled them out of that function and threw them up at the top here. That's why you can see them up at the top. And I also added in some custom code there, which we'll talk about here in a sec. So let me get rid of that. Do a code view on that guy, and that's why now you see that these variables here are now global. So this is what's actually used to read the data from the UART, And this is called every 200 milliseconds. So there might be garbage data. We might have a length of only 0 there. You know, I mean, like there might just not be any data in the buffer. That's why if the length is ever greater than 0, we want to first blink the LED so we know that some data came in. So you can see we've got a GPIO right. And remember, the LED is on pin 0 of the BLE board, which I do have set up here. Not great documented code there, but anyway, you get the idea. So pin 0 is an output, and then this is how we write the pin high and then the pin low. And then I don't think I talked about this last time, but this is how you do delays. Okay, and this is a delay in microseconds, so it's at 10,000 microseconds or 10 milliseconds. So we just want to flash that LED. And then right here I'm doing an sprintf, and basically what this does for me is it copies the contents of buffer into a new variable message only when the length is greater than 0. So when we have good real data, I want to grab that and keep it. Okay, and the only reason for this is so that when we go through this whole thing, when we have that 9th bit of data, I want to be able to save that message now and set it as the new value, because this over here, this task, let me scroll over there, is continuously running every 200 milliseconds. And if any, you know, if we used buffer over here, that it could be too late by the time we get over there potentially, and then, you know, we would clear the window out and we would lose that 9th message there, that 9th piece of information that came in from the UART. Okay, so that's the whole point there. Okay, so yeah, that's pretty much it. So we copied the contents from buffer over to message as a string format, and you're going to see me use a lot of sprintfs in this code or in future tutorials as we go along here. Okay, so that's pretty much it. Down here, though, like I mentioned before, is the code that handles the line counting. So, you know, we have this function here, this count lines function, and it's just keeping track of the lines. And every time the Arduino sends us a new message, it's with a new line character at the end. You know, we're always doing print lines. So we're always going to have that new line. So that's why every time we have good new data that's greater than 0, we're going to increment this variable line count. And if it's ever greater than 8, we know we've got 9 lines. Reset the line count back to 1 because, again, we are not going to be at 0 because whatever that 9th bit of data is will go in at line count 0, right? So, and then we return 9. And then going back here, you can see in the expression we do that check. But what's interesting here is in this connector here, we have to do a couple new things. So let me pop that open real quick here. So there's a few interesting things here and a couple gotchas, I guess. But what we want to do is when a value is returned from this function, we want it to evaluate this. We want to trigger the evaluation. So that's what we're doing here with this thing here. And then I created a new trigger. You can just hit the plus symbol there to create new triggers. And what I wanted to do here was add a value. And the reason I'm doing this is I have to add a value for the evaluation here. So whatever the value is returned, we get that value, and then we're going to add a value, okay? And then with the key of counter, okay, with the value, okay? Now hold that. I know this is confusing. But what we're going to do now in the expression, so look, we have the key counter at the value. So now we could have more than one value. So we have values dot counter equal to 9. Okay. So we had all kinds of different things in this connector for the values coming in. We could add all kinds of different values. Which you'll see in a second because I've got some other code. Well, maybe not in this project, but you'll see in future projects where I'm adding a lot of different values and keys and all kinds of things for that evaluation. So that's why you do it that way. And then over in the expression here now, we just pull it out of all the values that were coming into that expression. We look for the key counter, and that is what was returned by this function. Okay, so now, only if that's true, You see, if the expression is true, execute the next function. What's cool here is that, we want it to block right at this point. We don't want to clear the window, obviously, every time this is called. So that's what this does. It blocks it right there. And when it's true, when we do have 9 lines, we execute this clear window function. And again, nothing in there, just a very simple thing. It returns the message. Okay, it returns what was copied over up here from the buffer when we had good data, which was that 9th message, right? So pretty simple stuff. And then it, like I said before, sets the label. Okay, and that's all there is to it. Now, a couple other things we've got here. So the code that handles the sending of data from the BLE board back to the Arduino is right here. So we've got a simple button that we've got this, let me click on that. I'm having problems with my mouse right now. I can't get it on there. So yeah, there we go. So when we click on that button, the source is static because there's nothing coming from the button. And we just want to trigger the text box here. And then over from the text box, we have a connector. And we want to grab, on trigger, we want to grab the value in that text box and then execute the UART write function and bring along the value from that text box. Okay? And then in that, we'll take a quick look at the UART write here. So yeah, check it out. So in the UART write, what I'm doing again is the sprintf. And this is just a nice way of formatting stuff. So I'm bringing in the data. And I'm bringing it over back into data. So I'm just taking data and then creating, just overwriting data with data as the string here. But I'm adding in a new line feed character. Okay, so over on the Arduino side, it's always creating a new line. Okay, as part of that string that's being sent over. And then we just send the whole thing over, and that's it. Okay, that's all it takes to send data over from the BLE board to the Arduino side. Okay, and then the last thing I've got going on over here is a little connection status. So there's a label down here that tells us if the BLE is disconnected or not. And I know I call it BLE, it's Bluetooth Low Energy. But if the BLE is disconnected, connected, connecting, or disconnecting, we can get all that information from this element here. So you can see from the connection status element here. Let me click this connector here. Come on, there we go. So we have all kinds of triggers here. So we've got, I created all these triggers here. When you just click new, you can see all of your different options. So we have an option for connecting, connected, disconnecting, disconnected. So when, like for example, this one, connecting. Target will be set value, and we want that value to just show BLE connecting. Okay, so we actually see that in that label. I've got one for connected, BLE connected, disconnecting, connected, and you can use this to set up, auto connect type projects, or only connect to, devices with this name or this address. And we'll talk about that in future projects, but this is just kind of cool. The other thing I'm doing here is clearing the lines. So I have another function here. So like, when I connect for the first time, I want to just clear the console window there. So look, you can see that this does nothing but calls this function here, and I can jump right into this. So the clear lines here just sets line count back to 0. And you can see it also, let me click that. So when it's connected, it sets the value of the serial window up here to blank. Okay, so that's why you see the double quotes in there. So it just blanks out that entire window, clears it out. So when you connect for the first time, clears out the window, clears the line count, and we also have the nice connection status down there. Okay, so that's pretty much the whole project. I hope that makes some sense. Just quick little mini project there. In the future, I'm going to have buttons and sliders and all kinds of stuff, and I think I'm going to use the UART interface there to communicate back to an Arduino. We'll control WS2812 LEDs, stepper motors, all kinds of stuff. And I'm going to do it all with the UART interface. So anyway, again, I'll have all of this available for download so you can play around and have some fun with this project and modify it. So Anyway, quick video there. I guess not so quick, but hope that helps. Thanks for watching.